When it comes to describing solutions, we can describe the concentration in a variety of ways. And a lot of how we describe our concentration is going to be dependent on what information we're interested in or what information we actually need about that solution. So common concentrations are going to be things like molarity. We'll use that commonly if we're doing chemical reactions and we need to actually know the moles of a substance. We'll use molality when we're talking about properties of a solution. And then our final concentration we can see in a variety of applications, and that is the mass ratio concentration. So mass ratio concentrations are used primarily, although not always, but used primarily when molar mass is unknown. So we could be dealing with some random substance, or we could get into more complicated molecules such as polymers where molar masses may vary. But when we talk about a mass ratio, as that name implies, it's a ratio of masses. And so one type of mass ratio we can look at is the ratio of the mass of a solute to the mass of a solution. And we're going to look at three types. We've got mass percent, parts per million, and parts per billion. All of these are a ratio of the solute mass to the solution mass. The only difference is the multiplier. So if we're looking at a percent, we're multiplying by 100. If we're looking for parts per million, we're going to multiply by 1,000,000. Parts per billion, we're going to multiply by 1,000,000,000. So if we know masses of solutes and solutions, we can calculate any of these mass ratio concentrations. But very similar to any of our other concentrations, when we have this ratio, we've got these fraction units. These are conversion factors. So the examples we're going to take a look at is how we can actually use mass percent to get information about our solutions. So looking at problem number 8, we're asked how many grams of sucrose are contained in 355 milliliters of a soda that is 11.5% sucrose by mass. So we've got a lot of information here. Again, we always want to break down who's the solute, who's the solvent, who's the solution. So we've got grams of sucrose being contained in soda. So the sucrose is the solute. It's contained in soda. Soda is a mixture of all kinds of things. So the soda itself, that's our solution. And it's not mentioned here, but soda is aqueous, so water is our solvent. So we are looking for grams of our solute. Now, the information that we have in terms of the amount of a substance, so a given mass, volume, or moles, is the volume of our solution. So somehow, we've got to get from the volume of our solution to the mass of our solute. Now, solute and solution are going to be related through concentration. So we look to see if we have a concentration here. And my concentration is a mass percent concentration. It's 11.5% sucrose by mass. When we look at that concentration, that 11.5% means that I have 11.5 grams of sucrose present in 100 grams of my solution. So that's what a percentage means. It's the amount out of 100. So if I have 100 grams of solution, 11.5 grams of it is my solute. So that concentration gives me a relationship between my solute and my solvent. But now if I take a look at what I actually have, I have the volume of my solution. In order to use that mass percent to get solute information, I'm going to need the mass of my solution. So I'm going to need to take my volume and convert it to grams of solution. And we can always convert between volume and grams using the density of the solution. And we're given that density right here. It's the 1.04 grams per milliliter. So that means we've got 1.04 grams of soda in every 1 milliliter of soda. So that's going to be the first step of our calculation. Now that just takes us to the grams of our solution. We're going to need grams of our solute. So again, my solution and my solute are related through the concentration. So here we're going to use that mass percent. And so we've just set our equality up here. It's 11 grams equals 100 grams of solution. So now we're going to set up our calculation. So we're going to start with the given mass or volume, which is the volume of the solution, the 355 milliliters of soda. We're going to convert those milliliters to grams using our density. We want to cancel milliliters, so the 1 milliliter side of our equality goes on the bottom. The gram side, the 1.04, goes on the top. So my solution volume cancels, and I'm left with grams of soda, or grams of my solution. So that was our step 1. Our next step, we're converting grams of solution to grams of solute using the mass percent. When we go to set up our next conversion, this time we need to cancel the solution mass, or the soda mass, which is going to be 100 grams. So my 100 grams of soda goes on the bottom. My 11.5 grams of sucrose goes on the top. So that my soda grams cancel. And I'm going to get 42.5 grams of sucrose. So the 42.5 grams, that is 11.5% of our total solution amount. Now, of course, you can solve these problems other ways. We're going to continue to look at using our dimensional analysis or our factor label method throughout this semester. But you could have solved this other ways. You may solve it algebraically. As long as you're getting to that right answer and showing your work, then you're good. But we're going to keep this method up, and we're going to continue to use it in all of the examples we work throughout this semester. Now, looking at our next example, here we're being asked to calculate the volume of concentrated sulfuric acid that is 85% by mass that would contain 40 grams of pure H2SO4. So this one can get a little tricky in terms of making sure that we identify the solute, solvent, and solution, and identifying what these numbers we're given belong to. So, concentrated sulfuric acid, that's my solution. If we're not told anything, we're assuming our solution is aqueous. So to get that concentrated solution, we're looking at H2SO4 being dissolved in water. So when we're told pure H2SO4, that's the solvent, that's the solute that is being dissolved in the water. So my solute is the pure H2SO4. It's being dissolved in water. Water's the solvent. Together, they make the concentrated solution of sulfuric acid. So now we take a look at what information we're looking for, and we're being asked to calculate the volume of our solution. So then we take a look at what information we're given. And when we're trying to identify what we're given, again, we're looking for mass, volume, or moles. So things like densities, things like percents, we can set those aside for right now. They are useful information, but right now we're looking at a starting mass, volume, or moles. So I'm given the mass of my solute. So that is the information I have to start with. So similar to our other problem, we need a relationship between the solute and the solution. And solutes and solutions are always related through concentration. The concentration that I have is a mass percent concentration. So what I can do in order to get the volume, I need to go through mass. So what I can do is I can convert the grams of my solute to grams of solution, because that's what the mass percent relates. This means we've got 85 grams of H2SO4 pure in 100 grams of our solution. So that's our first step. We're going to use that mass percent to convert grams of solute to grams of solution. Once I have the mass of my solution, the mass of a substance and the volume of that same substance are always related through the density. So my next step is we're going to do grams to volume using the density of the solution. And I'm given the density of the solution. So the fact that that density follows the word concentrated sulfuric acid tells me that is the density of my solution. So now putting this all together, I'm going to start with our given mass of 40 grams of the pure H2SO4. We're writing it as a fraction over 1, and we're multiplying by a conversion factor. Our conversion factor is going to be made using that mass percent. I need to set this up. So again, we've got to be careful with solution versus solute. I need to cancel my solute moles. So I'm going to put the 85 grams of my solute on the bottom, with the 100 grams of my solution on the top. That way my solute grams cancel, and I'm left with solution grams. So that's step 1. My next step, I need to multiply by another conversion factor. This time that conversion factor is coming from the density. It's the density of the solution. In setting up this conversion factor, I need to cancel my solution grams. So the grams, 1.84 grams of solution, goes on the bottom with the 1 centimeter cubed on the top. That is going to give me a volume of 26 centimeters cubed for my concentrated H2SO4. Now I've got to watch significant figures. My starting number had 3, but we've got to remember that my concentrations are coming from measured numbers. My concentrations should be expressed in the appropriate number of significant figures. That 85% has only 2 significant figures. And we're using it here in our calculation. And when we're doing multiplication division, we go with the least number. So my answer here has 2 significant figures. So here on this slide, we've got a chart that summarizes different types of concentrations that you can encounter. There's some that we haven't talked about. They're just thrown in here because there are other possibilities you may come across. But we've got their units, their definitions. Again, what you guys will be responsible for is the molarity, molality, mole fraction, and parts by mass. Now, on your worksheet, you have an additional problem, number 10. So what number 10 does is it gives you guys practice with calculating all of these different types of concentrations. So we've gone through examples of all of them. It's going to give you practice with calculating those, as well as converting from one type of concentration to another. So you're being asked to determine the molarity, molality, mole fraction, parts per million or billion. If you haven't done so yet, I would encourage you to complete those problems on your own. There's an answer key to problem 10 that will be posted in the additional resources folder in Blackboard. So make sure that you check your answers. Concentrations, you need to get lots of practice because you're going to be using concentrations in lab all semester as well as in various chapters in lecture this semester.